Hello everyone, I'm Puya and today I'll be going over a few details about the Sudoku project. First, we're going to go over the Sudoku game and rules. Sudoku is a game that given an initial board, you have to fill the board with digits from 1 to 9 into boxes, such that every digit appears in every row, column, and 3x3 block. For example, here on the left we have the initial board and on the right we have the solved version of the board. Now, let's talk about the different classes within the project code and how you can use them to solve Sudoku. The first class we're going to talk about is the variable class. A variable is a cell in the Sudoku board, for example, the X that is highlighted in yellow. It contains row and column position of the cell and the block the cell belongs to, like the orange box around the cell X. It also has a domain. Domain is another class, which is a set of values the cell can be. Here, the X domain, aka the values X can be, is 5, 6, 7, 8. The reason why numbers 1, 2, 3, 4, and 9 are not in the domain is because they're present in either the same row, column, or block. On the other hand, the program represents values that have already been set as variables with a single item in their domain. For example, the 9 that is highlighted in blue has a domain of only 9. The class also has Boolean variables to keep track of assignments and modifications. There are also helper functions to remove a value from the variable domain or assign a value to the variable. We know every row, column, and block needs to have the numbers from 1 to 9. With only 9 spots available, it means that there are some constraints, and the way we define those constraints in Sudoku is a set of variables that cannot have the same assignments, such as cells in the same horizontal line, vertical line, or in the same block. So one variable belongs to 3 different constraints. Now we have the constraint network class, which represents the Sudoku game as a constraint satisfaction problem. This class contains variables, their constraints, and many helper functions. Here are some of the most helpful ones which you can use without implementing them yourself, such as getting the neighbors of a variable or getting modified constraints. Get modified constraints gives you the most recent constraints that have been changed. This function is super useful for the forward checking you will be implementing in minimal AI. Also, make sure to take a look at the descriptions of these methods and what they return. Now, since we're trying to solve a constraint satisfaction problem, we don't know whether the choices we make initially are the correct ones until we reach whether the board is solved or an unsolvable state, aka didn't. But how do we recover from an unsolvable state? This is where the trail class comes in. Trail class represents the changes we made to the board and allows us to backtrack those changes to a point where we can make another decision. This class uses a stack to save the history of the variable domains before we change them, either through reducing the domain or setting a value. Second is a trail marker. This allows us to save multiple changes due to an assignment. Finally, there's an undo function that restores the value from the trail and goes back to the same state of the variables before we made the last assignment by using the trail marker. Now, all the functions you need to implement will be part of the BT Solver class. It's a class that acts as an engine that solves the Sudoku problems. It contains function for getting the next unassigned variable. This can either be a basic one, such as getting the first assigned variable, or it can be done with some kind of heuristics, which you will be implementing in Draft AI and Final AI. Second part of the program is checking consistency. This can be either done without propagation, meaning whether the current board that you have is a valid one by itself, or through propagation or pruning, where you propagate the constraints of assigning a value to all its neighbors. The latter is the assignment that you will be implementing as part of the forward checking function in the minimal AI. You will need to use the assignment check function to check the consistency of the network in forward checking and return the Boolean results, unless you reach an unsolvable state of variables with 0 domain, and that is when you return false. Now, we're going to go through an example that hopefully will make it a little bit more clear on how different classes are used. Let's say you were given the following board to solve. We're going to go through the solve function that is available in the BT solver and an overview of the way engine works. So first, you select an unassigned cell, whether it be heuristic or not, and then you pick a value and you keep going and going and going until you reach either an unsolvable state, which you can backtrack from, or you reach a correct solution and you're done. In a way, you can represent the actions you took as a tree of changes. A quick example is seen here, where given the board on top, you first select the first available cell and try different values. And then you go to the next variable and the next variable, and you keep continuing, and you can create a tree of the decisions. Let's go through an example while keeping track of our board, variable domains, and our trail. As discussed before, we need to get the next unassigned variable. Here, for simplicity, we're using the basic one and getting the cell 01. Let's call this variable v. We set our trail marker to 0 because our stack is currently empty, and we push the domain of v, which is 579, into our trail. Next, we set the value of v to be the next available value in the domain, which is 5. Now, as part of the forward checking, we will need to propagate this new modification in constraint that we have added to the board, which is basically assigning v to be 5. If you take a closer look at the forward function description, it says that if a variable is assigned, in this case v, we need to eliminate that value from the neighbors. Now, who are the neighbors? Neighbors are the cells that are in the same block or same vertical and horizontal line. We will need to go through the neighbors that are unassigned, highlighted in yellow, and remove the value 5 from their domain. But before we remove it, we need to make sure that we push them to the trail to keep track of the changes. So for example, cell A, the only possible value for it before adding that 5 in cell V was 5. For B, we have 2, 4, 5, 7, 9. And for D, we have 1, 3, 5, 6. Now, you might ask, why don't we have E and C? Well, we don't have E and C in the stack because they already don't have 5 in their domain, so they're not being modified. Now, once we remove the value from our neighbor's domains, we notice that cell A no longer has a value in its domain. Well, this makes our board unsolvable, which is why we need to backtrack. To backtrack, we simply restore the domain from the trail by popping from the stack until we reach the trail marker. Now that we know 5 doesn't work, we go to the next value 7, and we keep going by repeating this until we solve the rest of the board. Now, remember, for this assignment, you don't need to implement the backtracking. This is already implemented for you through the solve function and the trail class. All you need to do is to make sure that you push any variable into the trail before you make a change. So for the minimal AI project, implementing the forward checking is the same as pruning the domains of neighbors. Make sure to push every variable to trail before you prune it. Use remove value from domain function to remove the assigned value from the neighbors if the value is already in their domain. If the neighbor's domain size gets to 0, return false. Unfortunately, the modified dictionary isn't used, so you don't have to worry about it. Just make sure that you return the correct assignment check or false as the second pair of the return value. Yeah, and if you still have any questions, feel free to reach out and post them on discussion. I'll be happy to answer them.